Well, ladies and gentlemen, last podcast of Unit 9. There's only one unit left, Unit 10. So today we want to learn, I'm going to put two words together. Hope it doesn't bother you. Solution stoichiometry. That's right, solution stoichiometry. Say it, stoichiometry. We're going to do the math of solutions. So we've already done some with molarities, and we're going to kind of tie it together. So bear with me as we rock on. All right. So solution stoichiometry. Hey, screen, you should go forward. Solution stoichiometry. What in the world are we going to be learning about? All right. Here's the key. Actually, this really isn't anything new that you haven't learned already before. The key is that you must always work with moles. All right, and how do you get moles? Okay. Actually, let me back up a second. Always work in moles. The key equation we've already seen before is M times V equals moles. The key thing on this equation is to write this down again, that the V must be in liters. And M, of course, is the moles per liter. And actually, if you look at it, moles per liter times liters over 1, the liters cancel and you get moles. So when you're doing a solution stoichiometry problem, M times V equals moles is your key equation. All right, let's do an example. 50 milliliters of NaOH. Now, it's still a stoichiometry problem. So when you have a stoichiometry problem, what do you always start with? The balanced chemical equation. That's right, the balanced chemical equation. So I'm going to ignore the numbers for a moment. I'm going to write down the reaction. So NaOH reacts with excess magnesium chloride, MgCl2. How many grams of MgOH2 are formed? So I've told you one of the products, which is MgOH2. And then the other product would be the sodium is going to get together the chloride. Now warning, I see a lot of students, they'd write NaCl2. And that would be wrong, very, very wrong. Very, very, very wrong. How do you do this? It must be Na positive, chloride negative. So when you put these together from the charge game, it's just NaCl. Now that's an unbalanced equation. So to balance that equation, I would need to put, I got two chlorines here, so I'm going to have to put a 2 in front of this and a 2 in front of that. And these are ones and ones. Now, what do I know? I know that I have 50 milliliters. I'm going to write down what I know underneath what I know. I have 50 milliliters of the NaOH. So 50 milliliters. And it is 0.10 molar. And the question is, how many grams of the magnesium hydroxide are formed? We just have one step to do. So if I were to take M times V, all right, so if I do MV with this right here, so I take 0.10 molar times this, I'm going from here, times 0.050 liters. Now I just converted to liters in my head. I divided by 1,000. So I have my calculator here. So 0.1 times 0.05 gives me a pretty small number. This is 0.005 moles. Now moles of what? Moles of sodium hydroxide. So I say moles of NaOH over 1. Now it's just a stoichiometry problem. And then I'm going to say there are 2 moles of NaOH. Where did I get the 2? That's from right here, right? For every 1 mole of MgOH2. It's kind of a shorter stoichiometry actually, because I did this first step up here first. And now I just need to find the molar mass of MgOH2. Now Mg weighs 24 plus oxygen, there's OH is 1670, 17 times 2. This is my calculator. This has a molar mass of 1 mole of MgOH2 to 58 grams of MgOH2. Notice I have no naked numbers here, right? So the moles of NaOH cancels, the moles of the magnesium hydroxide cancels, and so I'm going to take my 005 number divided by 2 times the 58, and I get 0.145 grams of MgOH2. And that's the answer. You see, the key is M times V equals moles. Let's do a second example. All right, I got HCl reacting with zinc. So let me start with a blank screen. So I've got HCl. Notice I don't bother with the numbers just yet. And that's going to make, what is that going to make? Well, this is a single replacement reaction. So the zinc is fighting for the chloride. He wins. So it's going to be ZnCl2. Now, how did I know it was 2? Again, it's the charge game. Zinc is +2 and chloride is -1. Plus, tricky on this, H2. Remember, he's diatomic. Hydrogen always exists as 2. To balance this, I'll need to put a 2 right here. Good? Now, let's take a look. I have 20 milliliters of 0.1 molar HCl. So HCl is 20 milliliters and 0.1 molar. Now, what's it asking me to find? What volume of hydrogen gas at STP? All right, so I'm going to put V at STP. So I can, with STP, I can use that 22.4 liters per mole number. All right, so this is simple stoichiometry. I do have to watch this, and then I have to do the M times V. So M is 0.1 molar times my volume, which will be 0.020 liters, right? So 0.1 times 0.02 is 0.002 moles of HCl. So if I do that 0.002, probably 0, an extra digit there, moles of HCl over 1. There are 2 moles from the balanced equations of HCl, that's from the 2 right there, right, for every 1 mole of hydrogen. And that's, of course, because there's a 1 right there. And if I'm just going to STP, I can then just say 1 mole of hydrogen is equal to 22.4 liters of hydrogen, because it was at standard temperature and pressure, STP. So now I just take 0.002 divided by 2 times 22.4 gives me 0.022 liters of hydrogen. Not too bad, is it? All right, one more example, I think. All right, we got barium chloride and sodium sulfate. All right, so barium chloride, BaCl2, plus Na2SO4. Now this is a double replacement reaction, so it's going to make BaSO4 plus NaCl. You got to play the charge game on this because you need to get these sodiums. You play the game. Sodium still has a charge of 1, chloride -1, barium, as you recall, is +2, and sulfate is -2. Now to balance that, yeah, that's a balanced equation. Now what do I know here? I know I have 150 milliliters of 0.15, 150 milliliters, and it's 0.15 molar. All right. Now the sodium sulfate is 55.3, 55 milliliters, and 0.3 molar. Now wait a second. We have 2 different M's and V's, don't we? So this is a limiting reactant and solution stoichiometry problem. So I'll do M times V. So I'm going to just do that on my calculator. Now this 150 becomes 0.15. So it's actually 0.15. 0.15 times 0.15. So the number of moles here is 0.0225 moles. And I take M times V, that'll be 0.3 times 0.055, 0.3 times 0.055 gives me 0.0165 moles. And then you have a limiting reactant problem, and the question, if you recall, was what? Grams of precipitate are formed. Okay, which of these 2 is the precipitate? Well, you'd have to use your SAQ table, your solubility table, if you recall. Turns out when you look at that up, barium sulfate is soluble and is solid, pardon me, and sodium chloride is aqueous. So the precipitate is the solid product. So the question mark is how many grams of the barium sulfate. And so it is a limiting reactant. So you would convert the barium chloride to the barium sulfate, and then the sodium sulfate to the barium sulfate, and the lowest one wins. However, we do have a bit of an advantage on this particular problem. We could save a shortcut. Now I want you to look at it carefully. What do you think that advantage is? That's right. Hopefully you see this. Since the ratio here is 1 to 1 to 1, since this gives 0.02 moles and this is 0.016 moles, then the mole-to-mole ratio, the one that's going to give you the lowest answer, is clearly the sodium sulfate. Now, if you were to do both stoichiometric lines, the lowest one would win, but there's no question the lowest one will be the sodium sulfate. So you'll take 0.0165 moles of sodium sulfate, Na2SO4, and then the mole-to-mole ratio being 1 mole to 1 mole, 1 mole of sodium Na2SO4 to 1 mole of BaSO4 And now we simply do the molar mass of the barium sulfate. 1 mole of BaSO4 to the grams of barium SO4. Turns out when you add it adds up to 233 Ba plus S plus 4 O's. So now we just take our number, 0.0165 times 1 divided by 1 times 233. And you get 3.85 grams of barium sulfate. So it's a limiting reactant problem, but you could do a second stoichiometric line, but you would get a number larger than 3.8. I think on the worksheets you're going to have to do them both. It won't be quite so clear. So, sorry. Well, that concludes the last podcast of Unit 9, and you are getting close to the end. We'll talk at you later. Bye.